Hey everyone, good morning. I am Priyanshi Agrawal and welcome back to my YouTube channel. Now we are going to see today's Leetcode daily challenge, which is find minimum time to reach last room first. Okay, so let's see what is this question and how we can solve it. So in this question you are given that there is a dungeon with n cross m rooms arranged as a grid. Okay, and you are given a 2D array move time of size n cross m where move time of ij represents the minimum time in seconds when you can start moving to that room. Okay, you start from the room 0, 0 at time t is equals to 0 and can move to an adjacent room. Moving between adjacent rooms takes exactly 1 second. Okay, and you need to return the minimum time to reach the room n-1 and m-1. Two rooms are adjacent if they share a common wall either horizontally or vertically. Okay, so what you have been given in the question that you have been given a n cross m 2D grid where you can start moving to a room if you have that, if you are at that time, and moving to a room takes 1 second. So you need to return the minimum time to reach the room n-1 comma m-1, and you can start, you have a single source from to start moving, which is 0, 0 at time t is equals to 0. Okay, so let's see it with the test cases given. So see, in this test case you have been given with this grid n cross m with these values 0, 4, 4, 4. Okay, so you can start moving from the cell 0, 0 at time t is equals to 0. Okay, so let's say at time t is equals to 0 you start moving to this room, t is equals to 0, but you can't move to this room at t is equals to 0 because you should be having t is equals to 4 at least to start moving to that room, as you have been given in this question, that represents the time, minimum time when you can start moving to that room. Okay, so you have to wait for 4 seconds to start moving to that room. Okay, now we are at t is equals to 4 when you can start moving to that room, and moving to a room also takes 1 second, as you have been given here. Moving between adjacent rooms takes exactly 1 second. Okay, so at t is equals to 5 you are finally at this room. Okay, now can you start moving to this room? Yes, because you have already crossed the point of t is equals to 4. So at t is equals to 6 you are finally at this room if you have taken this path. Okay, or you could also have taken this path. So as we can see, the values are same. So finally the minimum time required to reach the cell n-1 comma n-1 will be t is equals to 6. So let's match it. Yeah, its output is 6. Okay, now let's see some other test cases as well. So in this test case all the values are 0. Okay, so let's say you start moving from this cell 0, 0 at t is equals to 0. Can you start moving to this cell? Yes, you can, because this is the time, this is the minimum time which you should have to start moving to that cell. Yeah, you have this time, so you can move to this cell in 1 second. Now you are at t is equals to 1. Okay, so can you now start moving to this cell? Yeah, you have already crossed the point of 0, so you can start moving to this cell at t is equals to 1. Now you have taken 1 second to move to this cell, so that's why t gets updated to 2. Okay, now can you start moving to this cell? Yeah, because you are at t is equals to 2, so you can finally move to this cell and your time becomes 3 because you took 1 second to move to this cell. Okay, so the minimum time required to reach to the cell n-1 comma m-1 from 0, 0 is 3. Okay, so you can see here its answer is 3, right? You could have taken, let's say we have explored this path in this question, this one. You could have taken this path or this path or this path, anything. Like you have to explore, you can explore all the paths or something, but like now we are trying to understand the problem, but we will see how we were going to approach it. Okay, now let's see the one more example which is given in the question. So here what you can do, you can start moving from this cell. Either you can move to this cell or you can move to this cell. Okay, so let's move to this cell as both the values are same. So at t is equals to 0, can you start moving to this cell? No, so you will have to wait for 1 second. Okay, now can you start moving to this cell? Yeah, you can. So now you will move to this cell in 1 second, so it will get updated to 2. Okay, now can you start moving to this cell? Yeah, you are at t is equals to 2, so you can start moving to this cell. Now you will reach to this cell and t will get updated to 3 because you will take 1 second to reach to this cell. So this is the minimum time to reach to n minus cell n minus 1 comma m minus 1 from 0 comma 0. You can see in this output as well. Its answer is 3. Okay, so I hope you get the question, like what it is asking to do. Okay, so how we can approach it? So the very brute force approach for this comes to your mind, which might or might not be correct. We will see how comes to your mind is that let's take some other example. So let's say it is 0, it is 1, it is 5, it is 20, it is 1, 1, 1, it is 100, it is 30. Cool. Okay, very basic approach which can come to your mind is that let's say if you start moving to from this cell. Okay, so either you can move to this cell or you can move to this cell, right? So you will see the minimum time, which has minimum time, because for moving to this cell you have to wait for 5 seconds, but for moving to this cell you have to wait only for 1 second. So let's say if you now you have started moving to this cell after the t is equals to 1, and at t is equals to 2 you reach this cell. Okay, now at this cell you can either start moving to this or this, but you will choose the minimum one. Okay, so you will wait for 20 seconds, you will wait till 20 seconds, and at 21 second you are at this cell. Okay, now you can start moving to this one, so it will become 31. Now at this one it will finally become 32. Okay, but is this the really the minimum time which is required to reach this cell? Okay, according to you, you choose the local minimum every time. You choose the local minimum point 1, and you got this answer, right? Because at the 0th cell you checked which are the minimum numbers, 1 or 5. You took 1. Now from 120 you took the minimum 1. Yeah, so in this way you got this answer. Okay, but is this really correct? Let's check it with one more path. It is 0, 5, 1, 2, 100, 20, 30, 1, 1. Cool. Okay, so let's say if you have taken this path instead of the 1, if you have taken this one. Okay, so let's see. You have to wait for 5 seconds, and then at 6th second you are at this cell. Okay, now at 7th second you are at this cell. Now at 8th second you are at this cell. Now at 9th second you are at the cell n minus 1 comma m minus 1. Right? So what you can see, the local minimum is not going to work here. You have to explore all the paths. You have to explore all the parts to get the minimum time needed to reach the cell n minus 1 comma m minus 1. Right? So I hope it's clear from this example that you can't just take the local minimum at every point. You can't just decide randomly that yeah, this is minimum from both of them, so I will take this path, and then I will get my minimum time. No, you can't. You have to take the global minimum. You have to explore all the paths. Okay, so now let's see how we can explore all the paths. So can we consider this grid like a graph? Let's see how. 0, 1, 1, 2. Okay, so this was the example. Okay, so let's see. So let's say this is the 0, 0th node. This is 0, 1 node. This is 1, 0 node, and this is 1, 1. Right? These are the 4 nodes. Obviously, a 2D grid can be represented in the form of a graph. Okay, which has edges among them, right? They have edges among them. And what are the edges like? And they are weighted edges. Why? Because this is the time you need to wait to start moving to this cell. It means this is the value you should have to reach to the adjacent node. So let's say its value is 1 and it will take 1 second to move to that cell. Similarly here it is also 1 second, 1, and it will also take 1 second to move to that cell. And similarly here it is 2 and it will also take 1 second to move to that cell. And here also it is 2 and it will take 1 second to move to that cell. So can we consider this 2D matrix in the form of a weighted graph? Yes, we can. Okay, now in this weighted graph, what we need to do? We have given a single source, right? We have given a single source in the question, and we need to reach to the destination n-1 comma n-1, and we need to find the minimum time, right? We need to find the minimum time. It means, can we call it as shortest path? Obviously, instead of the distance, we are just referring to the time here, right? So can we call the minimum time as the shortest path? Like we are asked to find the shortest path in a weighted graph when we are given a single source, right? From 0, 0 to n-1, n-1. So can you relate this graph problem to the algorithm, like Dijkstra algorithm? Dijkstra's algorithm is used to find the shortest path in the weighted graph, right? So in this question, we can use the Dijkstra algorithm to find the minimum time to reach from cell 0, 0 to n-1, m-1. Okay, so now let's talk about Dijkstra algorithm, like what it is and how it is used. So in the Dijkstra algorithm, what we do, we have a priority queue which stores the time needed to reach that node and the node which we are reaching, right? And we also have a result vector, or we can say time or distance vector, what you want to refer as, which have initially all the values as the infinite, and each index refers to the minimum time or index needed to reach that node from the source node. Okay, so in this question we have been given with a 2D matrix, right? So our time or result vector is also going to be a 2D matrix, right? And our priority queue is going to store the int, which is the time, and the pair of the node, right? Cool. Okay, so what is the algorithm for Dijkstra? Like what we do in the Dijkstra? So we will initially push the source node in our queue, right? With the time is equals to 0, because 0 time, now no time is needed to reach the 0, 0th node. Okay, now we will check for all of its adjacent nodes and we will see. So let's say initially this result vector is filled with all the infinities excepting the source one, right? Okay, now we will check for its adjacent nodes. So we will find out the new time which is required to reach to this node from whatever path we are coming, right? So what will be the new time? So the new time will be the maximum of the move time plus 1, right? Move time, because this time is needed, at least this time is needed to reach to this node, or the time which is this, let's say I will refer to as this as t or t plus 1, right? If this is already greater than the move time, then we have to take it. If it is less than the move time, then we will have to wait till the move time of I to start moving to that cell. So this is the new time, right? So we will check if new time is less than, let's say this is a result vector, if the new time is less than the result of let's say I will refer to as I and j right now, ij, then what we will do, we will simply update our result vector with the new time, because it is less than the time which is already stored in the vector, and then only we will push that in our queue, new time comma I and j, right? So this is the basic logic for the Dijkstra algorithm, that we will initially push the source node in the queue and we will start iterating for its adjacent nodes, and we will find out the new time which is required to reach to that node, and if that new time is less than the already stored time, then we will update it and we will push that node in the queue. And finally, result of n minus 1 m minus 1 is going to give us the final answer, this one, because this is going to store the minimum time which is required to reach this cell from the source, right? Okay, so let's try code this so that you will get a better idea. Okay, so let's store the move time dot size in n and move time of 0 dot size in m. Okay, now let's declare a priority queue pair of int comma int, right? Okay, now let me just copy it. Now we need to declare vector comma greater. So in this way we can declare our priority queue pq. Okay, now we will push this source node in the queue 0 comma 0 with time t is equals to 0, and then we will also initialize our final result vector, which I will call it as time vector of size n cross m, initialized with int max. Cool. Okay, now it's 0 comma 0 will be initialized with 0, and now we will start iterating in our queue pq dot empty, and int t is equals to pq dot top dot first, right? Int row is equals to pq dot top dot second dot first, int column is equals to pq dot top dot second, right? And then we will pop out that element, and now we need to check for all the adjacent elements. So how we can check for adjacent elements? So we can declare two vectors like -1 0 1 0, and int d call is equals to 0 comma -1 0 comma 1, and then we can start iterating in these vectors to iterate on the adjacent nodes. I is less than 4, I plus plus, and we need to find int del row is equals to row plus d row of I hope you get it. Del call is equals to c plus d call of I, right? And we need to check these are under bounds, means del row is greater than or equals to 0, and then del row is less than n, and then del call is also greater than or equals to 0, and del call is less than m. This should satisfy it, otherwise we are at the side which doesn't exist, so it doesn't make any sense. Okay, now we need to find the new time. Okay, so the new time, let's say int move time is equals to move time of del row del call, right? And then we need to find the new time, which is going to be maximum of m time plus 1 comma this time plus 1, right? If this time is already greater than the move time, then we don't have to wait for any seconds. We can directly start moving to that cell, and this one for it, as it takes exactly 1 second to move to that cell. But if we are at a time which is less than the move time, then it means we have to wait for that much seconds, and then only we can start moving to the new cell. Clear? Okay, so now we need to compare if new time is less than the time which is already stored in our vector del row del call. If yes, then we will update our vector with that time, new time, and we will push it in the queue del row comma del call. Okay, so after when its citation gets completed, we will simply return time of n minus 1 m minus 1. Cool. Let's try run this. What I have done, oh, pq dot push. Oh my, okay. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexities a little bit. So as you can see in this question that we are iterating on all the cells of the grid, right? So how many cells it have? N cross m. So its time complexity will be big of n into m, and we are using this priority queue, and we are pushing the elements, pushing the nodes in the queue. So it in the priority queue basically, and priority queue sorting operation takes log n complexity, and we are pushing n cross m nodes. So its overall time complexity will become n into m log n m, right? And space complexity will also become big O of n into m, as we are using this time vector to store the value for every node. So yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.